Our second question, looking at standard heats of formation, again using our tool page, the Appendix C from our textbook. It reads, complete combustion of 1 mole of acetone liberates 1790 kilojoules. Let's write the balanced thermochemical equation. We are looking at a combustion pattern of a hydrocarbon. We'll begin with the skeleton, taking the acetone C3H6O. Following the pattern of combustion, we know to add oxygen, O2, forming carbon dioxide and water. The acetone needs to be balanced here, C's, then H's, then O's. I'm counting 3 carbons on the left. I'll begin with a 3 on the right. 6 H's on the left. I'll begin with a 3 on the right. C's and H's are working. Let's see if our O's have behaved. 3 times 2 is 6, plus 3 more give me a total of 9 oxygens. 9 minus 1 original reactant needs 8 more. I can place a 4 in front of the O2. 4 times 2 is 8, plus 1 more over here gives me the 9 to balance the right-hand side. Now let's turn this equation into a thermochemical equation, adding on the delta H. It says that it liberates 1790 kilojoules. Liberates is another word for releases, generates, gives off heat. It's an exothermic process, negative 1790 kJs of heat. Our balanced thermochemical equation, 1 to 4 to 3 to 3, with a delta H of an exothermic value, negative 1790 kJs. Now, using this information, together with the data from the standard tables of heat, let's calculate the enthalpy of formation of acetone, C3H6O. C3H6O is our target variable. If I started looking through on my standard tables, C3H6O isn't listed as one of those in my columns. Let's call that value X, our target. The oxygen is listed in our table. Again, targeting the acetone, C3H6O, our variable X. The oxygens, again listed alphabetically, O2 is a gas, has a value of 0. It takes no energy to build an element in its standard form. We'll record that as 0. 3 units of carbon dioxide. And again, through a combustion pattern, assume that everything comes out gases. Everything is quite hot during this burning pattern of chemical change. We'll find carbon dioxide in a gaseous form, CO2 gas. Onto the thermodynamic page, carbon dioxide as a gas is negative 393.5. We'll record that here, negative 393.5. Remembering, we'll need to distribute a 3, making it 3 times as large when we begin our math. Let's find gaseous water. Now, gaseous water is under the oxygens. For whatever reason, water got listed with the other oxygens. Gaseous water has a value of negative 241.82. Remembering, when we begin our problem, we'll need to take 3 times that amount to find the change. Our formula, products minus reactants, equals the heat of formation. Now in this problem, we know the delta H of this equation. It was given to us with the term liberates 1790 kJs. Negative 1790 kJs is equal to the sum of the products minus reactants. The products, carbon dioxide had a value of negative 393.5. We need to distribute a 3 due to its coefficient. 3 times negative 393.5 plus the water. The water, we found a value of negative 241.82. We'll need to distribute a 3 times negative 241.82. The sum of the products is written inside of these brackets, minus the sum of the reactant. The reactant has a value of x plus 0. X is our target, what we're trying to solve for, the value of kilojoules of acetone. We'll simply write minus x. Let's begin by simplifying that first bracket. Let's take 3 times the value of negative 393.5, and that is giving me negative 1180.5, plus, let's hit 3 times negative 241.82, and that simplified to negative 725.46. Now let's add these two values together to simplify that bracket. Negative 1180.5 plus negative 725.46 equals. I find negative 1905.96. 1905.96 is the simplified algebra inside this bracket. Now, here's what we know. Negative 1790 kJs equal negative 1905.96 minus x. We want to solve for x, simplifying. We'll bring the like numbers to both sides. I'm going to add 1905.96 to both sides so I can bring over 1905.96, and that will give us negative x. So hitting 1905.96, now I have it, 1905.96, and that's a positive sign on the left now, minus 1790 equals 115.96. That's equal to negative x. X must be, and again, divide both sides by negative 1. We'll flip the sign. Negative 115.96 kilojoules, the standard heat of formation for acetone, C3H6O. The original target value x we have just solved for.